Hello, algebra students, and welcome to lesson 7.5. 7.5 will be factoring binomials and polynomials, and so this section we actually split into two notes groups. The first one we'll be looking at factoring by the GCF, and then next in 7.5 we will be looking at factoring with magic numbers. So when we're factoring by the GCF, an important vocab word is greatest common factor, or GCF. This is the largest monomial that divides exactly into two or more monomials. So we've learned GCF, greatest common factor, as the largest number that can be multiplied into two other numbers. So if I say 6 and 4, the GCF is 2. Well, now if I had 6x and 4x, the GCF would be 2x, because both 6x and 4x have an x as well. So 2x would be the greatest common factor, the largest monomial that can divide into both of those terms. All right, so when we're factoring polynomials, first we're going to think, what do the two terms have in common? We're going to find the GCF. Then we're going to divide all terms by the GCF, and we're going to put the remaining terms in parentheses. So it's going to end up looking like a multiplication sentence. For example 1, I have 2x squared and 4. The second term, 4, does not have an x, so my GCF will not have an x, but both 2 and 4 are divisible by 2. So my GCF of 2x squared and 4 is 2. Step 1, find the GCF. GCF is 2, done. Step 2 is to divide all of the terms by the GCF. So we're going to take 2x squared, divide it by 2. So I'm left with just x squared. And then we're going to take 4, or negative 4, minus 4, and also divide it by 2. And I'm left with negative 2. So I put the remaining terms in parentheses, and notice my final answer looks like a multiplication sentence. All right, so next example, I have 8x cubed minus 4x squared minus 16x. I'm going to think, what do 8x cubed, 4x squared, and 16x all have in common? Well, all the number terms are divisible by 4, and then each term has at least one x. Notice this last one would have an exponent of 1, or it doesn't have an exponent, so I can only have one x in the GCF. So now I'm going to divide every term by 4x. I should have 3 terms inside my parentheses. First, I'm going to take 8x cubed divided by 4x. 8 divided by 4 is 2. X cubed divided by x is x squared. Then I'm going to take negative 4x squared divided by 4x. I'm left with negative 1x, or just negative x. And then negative 16x divided by 4x, the x will cancel out. 16 divided by 4 is 4. So again, notice my answer is a multiplication sentence. Notice there are 3 terms here, so there are 3 terms inside the parentheses. And if I took out and multiplied this 4x by the 3 terms in the parentheses, I would end up with what I started with. All right, and last example here, we're going to look at 2 terms with a negative. When both the terms have a negative, I can actually pull out a negative for the GCF. And then 14 and 12 have 2 in common, and there's an x and an x squared, so I'm going to pull out 1x for the GCF. All right, and now negative 14x divided by negative 2x is going to be positive 7. Negative divided by a negative is positive. And then negative 12x squared divided by negative 2x. Negative 12 divided by negative 2 is positive 6. X squared divided by x is x. So there is our final answer. All right, so now we're going to look at polynomials that actually have a binomial in common with their terms. So when we're factoring binomials, the terms must have a common binomial first to factor. And then we're going to take the terms in front of the common binomial, which in these cases are in parentheses, and then we're going to add them. So we're going to rewrite as 2 binomials being multiplied. All right, so let's look at example A. Notice how 5 times x plus 2 plus 3 times x plus 2 both have an x plus 2. Now you could think of these parentheses as just another variable. So 5x plus 3x, I could factor out an x. But there's an x plus 2 in both, so we're going to factor out the x plus 2, just like we did in the last example set. We're factoring out what they have in common. And now what I have left, if I take out the x plus 2 from the first term, I have a 5. If I take out the x plus 2 from the second term, I have a 3. So I factored out the x plus 2. I was left with 5 plus 3. So now I have 2 binomials left. And yes, if you're looking at this and you're like, I don't know what 5 plus 3 is, that's 8. You could simplify that to be 8 times x plus 2. But we're going to leave it in 2 binomials for now. All right, example B. We have negative 2b times b squared plus 1 plus b squared plus 1. Now, anytime you have a term by itself or a variable by itself, we always say you can put a 1 in front of it because 1 times anything is itself. Same goes here. We have a parentheses. We can put a 1 in front of it. That's just going to make it easier for us to keep track of how many terms are supposed to be in our second binomial. So both negative 2b times b squared plus 1 and then plus 1 times b squared plus 1 have a b squared plus 1. So we're going to factor out the b squared plus 1. If I take this term and divide by b squared plus 1, I am left with a negative 2b. And if I take this term and divide by b squared plus 1, I'm left with a 1. Now what a lot of students want to do here is they want to just say like plus 0 or even just forget about that second term. But we can't forget about it because then it's just being taken out of the entire equation. So we have to leave a plus 1 there. All right, that would be our final answer for example B. Okay, so I want you guys to pause for a second and think, can we factor example C? Let's look back at our directions here. It says they must have a common binomial. Example C does not have a common binomial. So we're just going to say we can't factor that. No common binomial, nothing to take out, can't factor. All right, for the last section of our pre-notes of 7.5, we're going to be looking at factoring by grouping. Now this is really just building off of factoring with the GCF, but it has an extra step. We're going to break it up into 2 sets of parentheses. So when we factor by grouping, we're factoring with 4 terms. When you have 4 terms, this is the best way to factor. All right, so step 1, we're going to break up the problem into 2 sets of parentheses. I'm going to go through example 1 while we're doing the steps because it's going to make more sense if you can see it. So break up the problem into 2 sets of parentheses. Just going to put 2 there and 2 there. Then we're going to pull out the GCF of both sets. So they must have a common binomial. That's why we're breaking out what we have in common. And that way what's left in the parentheses should be the same. Let's see what happens. 6h to the power of 4 minus 4h cubed. 6 and 4 are both divisible by 2, and both of these have an h cubed in common. 6h to the power of 4 divided by 2h cubed, I'm going to be left with a 3h. Negative 4 divided by 2 is negative 2, and the h's will cancel out. All right, so this part matches this part. Next, we have 12h minus 8. 12 and 8 have a 4 in common. There's no h in the second term, so I can't use that. 12h divided by 4 is 3h. Negative 8 divided by 4 is negative 2. All right, so this matches this. Now, we're going to do what we did in the last example where we factor out the binomial. Notice both of these terms have a 3h minus 2. So we're going to pull out that 3h minus 2, and then we're going to write what's left. So if I pull out 3h minus 2 here, I'm left with a 2h cubed, and if I pull out 3h minus 2 in the second term, I'm left with a plus 4. And there is our final answer. All right. Let's try the second one. I'm going to go back to blue. Okay, so 5y to the power of 4 minus 15y cubed. Both of these have y cubed, and then 5 and 15 are both divisible by 5. So I'm going to pull out a 5y cubed. I'm left with y, and then minus 3. The y cubes cancel out. Second set, we have y squared minus 3y. They only have a y in common. And then we're left with a y minus 3. Now we do what we did in the last example. So we're going to factor out the binomial and then add the terms in place in the parentheses for the second binomial. So we're going to factor out the y minus 3. If I take away the y minus 3 from the first term, I'm left with a 5y cubed. If I take out a y minus 3 from the second term, I'm left with a plus y. All right, there's our final answer. Okay, here's where I want you to pause the video and see if you can do C by yourself, and then play it back to see if you got it right. All right, here we go. 2x cubed minus 12x squared. They both have a 2 and an x squared in common. 2x cubed divided by 2x squared is just going to be x. 12x squared divided by 2x squared is going to be 6. The x squareds cancel out. Next I have 18 minus 3x. I'm going to factor out a 3, and I'm left with 6 minus x. All right, so here might have been where you got stuck. How we're going to fix this, instead of factoring out a plus 3 here, we're going to factor out a minus 3. So when I factor out the negative, 18 divided by negative 3 is going to be negative 6. And then negative 3x divided by negative 3 is going to be positive x. And now we know that x minus 6 is the same thing as negative 6 plus x. So now I'm going to rewrite this as x minus 6, knowing that that is the same thing as this. All I got to do is flip these terms around. And then what's left from the first term, this part, is 2x squared, and what's left from the second half is minus 3. That is our final answer. All right, and that was the pre-7.5 notes. This is the ultimate check. I want you to try this exit ticket all by yourself. Pause the video. I will run through the answer, and then you can make sure you got it right. All right, here we go. So first you should have split the quadnomial, 4-term polynomial, into 2 sets of parentheses. Then you should factor out the GCF. GCF of the first one is 6x squared. You have an x minus 3 left. GCF of the second one is actually just 1. X and minus 3 have nothing in common, so I have plus 1, x minus 3, which actually works out because then I have an x minus 3 in both parentheses. I can factor out the x minus 3, and I have 6x squared plus 1 left. There's your correct answer. All right, so in these pre-7.5 notes, we learned what is the GCF. It is the greatest common factor, or the monomial, that a polynomial has in common. How do you find the GCF? Well, you have to think, what do the numbers have in common, and then how many variables do they have in common? How do you factor polynomials? Well, we tried factoring the GCF out. We also looked at factoring binomials out, and then we also looked at factoring by grouping, which is really just throwing it all together. You have a quadnomial, you split it into 2 sets of parentheses, you factor out the GCF, then you factor out the binomial, and you're left with 2 binomials multiplying. All right, thanks for watching the notes video today. Please tune in to the Google Meet to see what your homework assignment is.